this problem here, there's actually a fairly simple solution to this, and we can find that without any trig. Well, we are kind of using trig. We can just slice this through here like this, and we can create 6 equilateral triangles that make up this hexagon, regular hexagon. Well, equilateral triangles mean that these sides are all exactly the same. So the diameter of the circle is going to be double this edge length, or 40. Okay. So if we didn't recognize that, we can still use trig by breaking this up into right triangles. So the right triangle that I'm going to use here, and there's lots of ways to split this up into right triangles, but to use symmetry and split it through the middle is the easiest way, because we can generate symmetry and we can find lengths much easier when we do that. Okay, some people may, start chopping it up like this and see if they can get a right triangle, and then, that's not a wrong strategy. However, it is not efficient because it's hard to figure out the lengths of these sides here without a little bit of work. So if we use symmetry and we just slice it through the middle like I did at the beginning, okay, we generate these equilateral triangles, and there's a triangle that I want right there. Okay, and that's really half of that's going to be half of a length. Okay, sorry, half of a equilateral triangle, and the edge length here is going to be exactly half of the edge length here. So if I have this, I know that this is going to be equilateral, or 60 degrees in here. So I'm just going to draw that again. Redraw that, and maybe just draw a little bit more proportionally correct. So this length is 10. There's 60 degrees in here. And really, if I can find one of the side triangle lengths here, okay, that will give me half the diameter. Okay, so that's what I'm looking for. So setting this up, I'm going to use, I want to solve for the hypotenuse. I have the adjacent side. So adjacent hypotenuses are ka, or cosine. So we know that cosine of 60 degrees is equal to the adjacent compared to the hypotenuse. Okay, cosine of 60 degrees from my calculator gives me 0.5. Okay, solving this algebraically, I get my hypotenuse is equal to 20, which is what we kind of expected. We know that that red length is 20. And so the diameter is then double that, which is 40, which we had figured out before. Okay, so like I said, there's a fairly simple solution to that if we understand that we can split this up.